Gracias por continuar con nosotros. Agradecemos que sigan en esta transmisión totalmente en vivo y damos inicio a la siguiente conferencia del bloque vespertino de este evento, UANL IT Summit 2021, con la conferencia Blockchain, a cargo de Natalie Smolensky, Head of Business Development. Natalie Smolensky dirige el desarrollo comercial de Highlands Credentials, una solución para credenciales verificables ancladas a la tecnología de blockchain. Como escritora y conferencista, se enfoca en las intersecciones de identidad, tecnología y gobierno. Smolensky ayuda a todo público a comprender la manera en que los individuos se conectan para formar comunidades y construir infraestructuras del futuro, aportando una perspectiva científica a las tecnologías digitales y a la transformación social. A nombre de la Universidad Autónoma de Nuevo León, para hablarnos acerca de blockchain, damos la bienvenida y cedemos la palabra a nuestra invitada experta, Natalie Smolensky. Welcome. Hi, how are you, Natalie?
I'm doing great. Thank you so much. It's great to be here.
It's great to have you. So we're going to talk about your conference, blockchain. So we're welcome you. So please.
Excellent. Okay, so I have some fun topics for us to talk about today. I'm going to talk about blockchain, and then I'm also going to talk a little bit about the value of blockchain specifically for education. Since UANL is using blockchain technology in partnership with Highland. So we'll talk a little bit about what that means and why it's valuable. And then I'm going to end by talking about the value of blockchain for digital identity. So we'll get into the next generation of blockchain-based technologies that are really empowering users and people all over the world to own their digital identities. So with that, I am going to share my screen. One moment here. And please let me know when you can see the presentation.
Yeah, we can see your presentation, Natalie. That's perfect.
Okay, perfect. All right, so quick agenda. Again, we'll start with an overview of blockchain technology, then we'll talk a little bit about the value of blockchain for education specifically, and then the benefits of blockchain for digital identity. So understanding the blockchain, you know, I'm sure that some of the people at the conference today are technical and they have a pretty good grasp of blockchain. For others, maybe this is something new. So I wanted to start out by providing a little bit of a history of blockchain. So, you know, what problem was blockchain technology really trying to solve? It was the problem of digital money. You know, ever since computers were invented, people were thinking through the question of, can we make money, paper money, digital? And of course, you know, we have digital ways of sending paper money, but the problem with those ways is that they are typically controlled by centralized third parties who charge fees or often can confiscate funds or do with our money things that, you know, we may not be comfortable with. And so the promise of digital money is that you could actually create digital assets with real value that are independently owned and held. So this problem was actually much harder than it seemed to solve, because anytime you digitize something or you make it digital, it can really easily be copied. It can also easily be edited. So you can't just create a digital dollar as a digital representation, for example. You would actually need to find some way to prevent people from, turning that one digital dollar into a million or 10 million digital dollars with the click of a button and then pretending they had all that money. And so what people began to work on is a way of sending money from one party to another. So instead of focusing on the digital representation of money itself, they began focusing on the ledger that kept track of who owned what exactly and who was sending what to whom. So this was a really important shift in thinking about digital money. And in fact, the main computer science problem that was solved here is something called the Byzantine generals problem. Now, this is a very old computer science problem. And the problem goes like this. You have a group of Byzantine generals trying to lay siege to a castle. The problem is that you don't know if you can trust all of those generals. Some of them may be traitors, and they may turn against you as you are going to attack the castle. And if even one of them turns against you, then your entire attack could fail. And so how do you ensure that that every single one of these generals is in consensus to lead to a coordinated attack that will generate a victory? Well, the solution to this problem was there were many solutions to this problem proposed over the years, but it wasn't until the Bitcoin white paper written by Satoshi Nakamoto that the solution really became finalized. That was really the solution to the Byzantine generals problem. And what Nakamoto proposed is that that we create a distributed ledger where every general or every node in the network contributes proof of work or computational effort to solving a cryptographic problem. And then the one who gets to the solution first gets to write an entry into a shared ledger. There were a number of incentive mechanisms that were also proposed in this paper to ensure the integrity of the network. For example, the network would be funded with an underlying cryptocurrency called Bitcoin, which would create value over time for people who maintain the integrity of the network. And so it disincentivized attacking the network because that would destroy value for everybody. And it also ensured that if there were bad actors, in other words, if some of these generals were in fact traitors in their hearts, they could not actually be traitors in fact, because the protocol proposed by Bitcoin is ironclad. And so what does this mean? It means that for the first time, we had a way of creating digital money that could be secure from people fraudulently misrepresenting how much of that money they had, misrepresenting who they sent it to or received it from. And that money, because it's cryptographically and computationally secured through the energy of proof of work, would create a robust system of sound money that was not issued by any government or any state, and not controlled by any government or any state. So the importance of Bitcoin for the world is still only beginning to be discovered. We're still in the very early days. A lot of people like to say, oh, Bitcoin is so expensive right now. It's too late, for me to really, buy any or even really learn about it. And that's just not true. We're just at the very beginning of a new system, potentially a new global financial system that is underpinned by a currency that nobody controls. So I've written elsewhere about what that means. I'm not going to go into too much detail in political economy today. But what I would like to do is back up a little bit from the computer science here and talk about socially why blockchain is such an important innovation. So, my background before I went into business was actually as an anthropologist. And there's a fascinating community in Polynesia on the island of Yap. And the reason that they are so interesting is because they have these possessions called Fey stones. And they're these huge stones that are their currency, their money. As you can see, each one of these stones is quite large. And so you can't actually carry it around. You can't give it to people physically. And so what happens is the Fey stones are actually arranged around the village, and they never move. So the only thing that changes is the ledger that is in people's minds about who owns which stone. And everybody has that ledger. So everybody knows that person A sent stone X to person B on this date. And person B now owns it. And then if person B sends the stone to someone else, then that will be recorded in the memory of the community. And so because everybody has a copy of the ledger, nobody can lie and say, well, that stone really belongs to me, because everybody knows that it does not. And so what this does is it solves the problem of one person or organization controlling the ledger. Because, if you have, let's say a centralized ledger repository, like a ledger controlled by a bank or by Visa or MasterCard or by a government, a centralized entity, they could change that ledger. And there is no recourse for ordinary people who hold money in that system. And so if the ledger is decentralized, then it doesn't matter how powerful you are, you cannot change the ledger. And that is why blockchain is such a democratizing invention, because it really doesn't see favorites when it comes to a record of truth of transactions that happened in the past. So, you can think of these Fey stones as very similar to Bitcoin. One Bitcoin is a lot of money. It's kind of, between 50 and 60,000 these days. But it likely will go up to much, much more, hundreds of thousands or even millions of US dollars per Bitcoin. And so most people will never own an entire Bitcoin. That's really a lot of money. But what you can do with Bitcoin is subdivide it into 100 million parts. So each Bitcoin has 100 million pieces called Satoshis, and anybody can buy those too. So, in some ways, the Bitcoin is like the Fey stone in that it's huge, and, most people will never own one. But because it is a digital currency, a natively digital currency, that means that anyone can own a part of a Bitcoin and just transact with that part. So that's very important. And it's an answer to the question people sometimes ask of, how is Bitcoin any different than gold, for example? And this is one of the ways, is that a Bitcoin can be subdivided into 100 million parts. A Bitcoin is bankable, so you can actually create a digital bank account and hold Bitcoin in that account. you can use it as a medium of exchange, which you can't do with gold. And because it's digital, it's really easily portable. Gold is physical, so it's hard to transport. And in fact, there are laws that if you're carrying more than a certain amount of gold, if you cross a border, it can be confiscated and taken from you legally. So digital currency is the future. That future is here today, but we're still at the very beginning of that future. Now, after Bitcoin was founded, the network first began in 2009. Soon thereafter, in the following years, other networks, other blockchain networks also sprang up. So most of them in the early days, they forked the Bitcoin code, which is all open source, so anyone can create a fork of Bitcoin, to create other networks with different characteristics and different cryptocurrencies funding the network. So Ethereum is the second largest blockchain network by market capitalization, but it has the largest ecosystem of distributed application developers and distributed applications themselves. It was designed to be, rather than a store of sound money like Bitcoin, Ethereum was designed to be a virtual computer. So a worldwide computer that specializes in a type of program called a smart contract, which allows actions, certain automated actions to occur if specified conditions are met. And then there are countless other blockchains as well, with many different cryptocurrencies. So, what is the blockchain? It's really a global verification network. It is a record of truth that nobody can edit or tamper with, that is shared across hundreds or even thousands of computers across the world. Now, there are different kinds of blockchains, and in fact, there's a category of networks called distributed ledgers, which some say should not be called blockchains. So there's a debate about the difference between blockchains and distributed ledgers. I created this chart here as a method of comparison. Not everyone would agree with how I've divided this, and that's okay, because there's not one right answer here. But in general, this is how I view the ecosystem. So on the one hand, you have public and private blockchains or distributed ledgers. So with a public chain, anyone can write to the chain and view the transactions. So you can actually all view every single transaction that's ever happened on the Bitcoin network or the Ethereum network, for example. It's all available to you on the World Wide Web. With private networks, you have to have permission to write to the chain and to view the transactions. And then there's also a distinction between open and permissioned networks. So who can run nodes of the network and validate transactions? In other words, who can be the Byzantine general? So with open blockchains, anyone can run the nodes and validate transactions. You do not have to be a trusted third party. Note here that open does not refer to whether the source code is open or not. So open does not mean open source. Open means anybody can become a validator of transactions, run a node of the chain. And then permissioned networks allow only permitted actors to run nodes and validate transactions. So there are various combinations of these networks out there. The most famous ones are the public open blockchains like Bitcoin and Ethereum. And those blockchains are funded by the native cryptocurrency. So you can think of those blockchains like a toll road, where if you want to drive on the road, if you want to, send someone money on the Bitcoin blockchain, you have to pay a fee. That fee is paid in the cryptocurrency of the blockchain network. So if you're sending Bitcoin from point A to point B, then you pay a fee in Bitcoin to the miners of that network who are actually validating the transactions. Same thing with Ethereum. So if you're sending Ether, which is the Ethereum cryptocurrency, you would pay a fee in Ether, and that fee helps support the people who maintain the network. So it's a sustainability mechanism. There's also mining, which we haven't talked about yet, but in short, many of these public open blockchains, they don't release all of their cryptocurrency at once. Like in the case of Bitcoin, there will only ever be 21 million Bitcoin, but those 21 million Bitcoin don't all exist yet. They have to be created. And the process of creating those Bitcoin is run by miners who perform the computational operations, the proof of work, to validate transactions, and then that mines Bitcoin, that produces new Bitcoin or new Ethereum. So those incentive mechanisms fund the maintenance and growth of the network, which is very important, because if it's not, if the network is not being maintained by a government or a company or a industry consortium or some other group that is funding this software project, which is very expensive, it has to be funded somehow. And so the cryptocurrency mechanism becomes a way for the network's costs, the cost of maintaining and growing the network, to be covered. Now, with the other types of blockchains, the public permissioned and private permissioned networks, they are more centralized, meaning that there is a governing body that oversees those networks. And a lot of them say, you know, we're very decentralized, but the reality is that there's always a permissioning process that actors have to go through to get access to that network. And so someone is giving that permission, and that someone is the governing body. So generally what happens is these public permissioned and private permissioned networks, they do not have a cryptocurrency. And so they are funded by the governing body, whether that is a foundation or a government or a company, a corporation or a group of corporations or some combination of all of those together. There is a group that funds the maintenance and development of those networks. The other really cool thing about blockchains is that once blockchains were invented to validate the transfer of money from one party to another, people quickly realized that they could also be used to validate all kinds of other things. So, you know, if you want to validate whether or not you graduated from university, well, you can actually use a blockchain to do that. This is a really interesting example from history. This is from the Inca Empire. The scribes of the Inca Empire kept royal records using this practice called quipu knots. So they would create these strings, and then they would create knots in the string when important things happened. And so this chain that you're seeing here is a historical record. The problem is that we don't know how to read it, because they stored all the information about what the knots meant off chain. So the scribe had to know how to read these knots, and they never wrote that knowledge down. So the last person who knew how to read these died hundreds of years ago, and archaeologists can try to guess at what they mean, but we will never know for sure. And so a blockchain actually works very similar, where the data that gets recorded to a blockchain is cryptographically secured data. So it's often hashes, pseudonymous or anonymous identifiers, and other types of data that is not easy to read or understand. But that data that's on the blockchain can be used to validate data that is stored off the blockchain. So here on the right-hand side, you can see databases, a smartphone, a laptop. So what that means is you can store the actual data on one of these devices, and then that data points to the Kipu knot, or the cryptographic hash, for example, that's stored on a blockchain, and verifies its contents that way without anybody ever needing to see the contents themselves. So it's a really ingenious privacy protecting mechanism that makes blockchains useful for many other things besides sending money. So let's talk a little bit about the benefits of blockchain for education. This is just a snapshot from a UNESCO 2018 study, students who study internationally every year. So by the year 2030, it's estimated that 7 million university students will travel internationally each year to study. That might be even higher. And this, of course, means that they will need a way of validating their credentials across many different countries. So, taking a look at some of the 21st century skills that are most important for students to learn. This is from the well-known book published in 2009, 21st Century Skills. Many of these are soft skills. Things like critical thinking, flexibility and adaptability, digital literacy. So those are hard to assess and give credentials for, but hard skills are still very important, and they are much easier to assess, to quantify, and you can issue credentials easily for those skills. So they're the most easily credentialed, and credentials are the most important for these hard skills. So, if you want to be a doctor or a lawyer or a technical expert or an engineer, you really need to have the right credentials to be able to practice in most jurisdictions. So that credentialing needs to also be digital, portable, interoperable, and verifiable. And this is where the blockchain comes in. So you can use blockchain as a kind of digital notary to register academic records. So you can take the document, you can run it through a hashing algorithm, and you can produce a hash that is then anchored to a blockchain. And so my company, Learning Machine, before we were bought by Highland, we collaborated with MIT and the W3C to build an open standard called BlockCerts, which is short for blockchain certificates. And this is the most widely used open standard for blockchain anchored records today. It allows any university or school to easily create and issue verifiable academic records to its students. So, BlockCerts it has a lot of cool properties in that it combines the easy human readability of a PDF with the machine readability of a JSON file. So the BlockCert itself is entirely JSON, which then generates a human readable presentation layer that looks just like a PDF. And what this means is that you now have fully machine readable documents that still have the look and feel of traditional records. These are then also encoded with cryptographic keys that identify the issuer of the record and the recipient of the record. And then the record is hashed, signed by the issuing authority with a digital signature that they own, and anchored to a blockchain for verification. So the issuer, like the university, for example, designs the record. They can make it look any way they want. They can add many different kinds of data to those records, either to the front or the back of the certificate. And then when it's anchored to the blockchain, they can choose whatever blockchain they want to use. So BlockCerts is agnostic with regards to the blockchain, meaning you can anchor it to Bitcoin, to Ethereum, to Hyperledger, to any blockchain or distributed ledger. This is how the verification stack works. So you can see here that at the very bottom, the blockchain serves as the record of truth. So the blockchain is the anchor that the record has not been tampered with. Then in the middle is BlockCerts, which is the data standard used to anchor these records to a blockchain. And then at the top is the software application that is used to design and issue the records, and that is Highland Credentials. So you can think of the application as akin to, it's like Google search or Facebook or any application that you would log into potentially online. And then you can think of the blockchain as TCP/IP. Which is, the internet protocol that is distributed and open and free. And then BlockCerts is kind of mediating between the application layer and the blockchain layer. So the result is verifiable academic records. And this is an example of a demo transcript from MIT. MIT was the first university to begin using this technology for their digital diplomas, and they still do to this day. So anyone who graduates from MIT is eligible to receive a diploma in BlockCert form. So for the student or the user, how do they receive their credentials? Well, they actually have a mobile app that they can download for free. It's the BlockCerts wallet, and it's available for iOS and Android. That wallet then generates cryptographic key pairs that identify them as the owners of the diploma. So, one of the problems MIT wanted to solve was, preventing someone from sharing their MIT diploma with someone else and the wrong person fraudulently claiming that they graduated from MIT. So the mobile app prevents that because it encodes that recipient identifier into every certificate. And then the wallet also keeps a record of every BlockCert that has been issued to that individual. So you can stack these up. You can have a whole group of certificates that add up to a higher level certificate and store them all in your private wallet on your smartphone that only you have access to. So for the educational institution, there are a number of benefits to implementing blockchain-based educational credentialing. First, you're improving efficiencies and security. So it's very cumbersome, difficult, time-consuming, and expensive to issue paper-based documents. If you can digitize that process, that's great, but that only solves part of the problem because a digital certificate can easily be edited or tampered with or fraudulently misrepresented. And so the blockchain component comes in to secure the digital version of the record so that you can be confident that you can issue these records quickly and easily, and nobody is going to change them or fraudulently claim that they graduated from your university. The other benefit is it really does enhance your brand visibility and reputation. So you're giving students a digital representation of their work with you, and they can share that with whomever they want. So we often see graduates sharing their BlockCerts diplomas on social media, putting them on their LinkedIn profile or Facebook where people can see them, on their personal websites. And that's basically free advertising for your school. So it really helps get the word out about the programs that you offer. It also empowers students. I mean, students love this. And every single customer we've worked with at Highland Credentials has done surveys of students to see how well they receive the technology. And overwhelmingly, the majority respond with, I want all of my records in this format. please issue everything to me like this. Because, you know, these generations, they are internet natives, they're mobile first. Many of them have never even addressed an envelope or sent physical mail by the time they go to apply for college. And so they don't understand why their academic records are still on paper in this, you know, difficult to keep track of and share and easy to fake. It just seems like a kind of ancient technology to them. So they love the control and the ability to do whatever they want with these records. And so that, you know, when you provide your students with a service like that, that strengthens your relationship with your alumni. And it also strengthens your relationships with the employers, the companies and government and nonprofit institutions who employ your graduates, because they can now immediately, with the click of a button, verify these people's credentials without needing to go back to the school and say, you know, can you please send me an official copy, or can you please, you know, apostille this, or verify that they really went to your school. The student can just, you know, send them a file or a link or show them their diploma on their phone, and they can verify it right away. So it really, you know, makes everything easier for everybody. The verification process is very clear and straightforward. You can verify these documents on your phone. You can verify them in a web browser. You can scan a QR code. So this is the direction that verification is going. Okay, so last chapter here, the benefits of blockchain for identity. And this is actually a continuation of the conversation about academic credentials, because, you know, in the same way that we realized we could anchor academic records to a blockchain and use blockchain as a digital global notary for academic records, you can do the same thing with any type of identity or claim. And so we are now on the verge of a decentralized digital identity revolution. And what that means is, according to Forrester here, this is not just a technology buzzword. It promises a complete restructuring of the currently centralized physical and digital identity ecosystem into a decentralized and democratized architecture. So what does that mean exactly, and why is it important? Well, I want to share with you today 10 principles of decentralized identity that have been very influential in the community of technical architects working on these new standards. Sometimes decentralized identity is called self-sovereign identity. I'm just using the word decentralized today to simplify it a little bit. But the whole idea behind decentralized identity is that it returns control back to the user. So these 10 principles are really important. The identity exists independently, meaning you control it. It can't be taken away from you. So think about something like your Facebook profile. At any time, Facebook can decide to delete your profile, suspend your account, delete all of your data, and they can also sell that data whenever and to whomever they want, because you're using their platform and you agree to that. That is an example of centralized identity where your identity only exists on that platform and the platform controls it. With decentralized identity, you control your identity, you own it, you self-host it. So you don't rely on a platform like Google or Facebook or Apple or a government platform, for example, to host your identity. You self-host it, and then you give others access to it. So you may use it on a platform like Facebook, but Facebook does not control the identity. So that independent existence is really important because it protects the user from, potentially having their identity erased, which in many cases, may not matter very much. You might lose some pictures and connections to friends, but if it's like a legal identity, for example, then you could suddenly find yourself, stateless, without legal protection, and very vulnerable politically. So that ability to control your own identity is actually, as some have argued, a human rights issue. Another principle here is that you control it. So you decide how that identity is used. You decide if you want to share data with a third party. You decide if you want to sell something to a third party. You decide how much data you want to share. And just under that, you can always access it. So, it's very common in centralized identity systems that you don't even know what your identifier is and you can't access it because it's all happening on the back end. There is no user-facing representation of that identity that you can access. And so if it's deleted or edited by somebody else who controls it, you don't even know. And this happens a lot in credit reporting systems. In the United States, for example, there are major credit reporting agencies that make their money by collecting data on people and then using that data to generate a report about how credit worthy that person is. So how fast are they at paying their bills, and if they have a credit history where they have lived. And then some of them may not have a credit history, and so sometimes academic records and grades are used to show how creditworthy they are. The problem with that is that there's no way to really guarantee that all the information they have about you is accurate. And it's common for people with the same name, to get confused and mixed up. And so sometimes, people can be denied credit because they have a low credit score because someone else with their same name, opened a credit card and never paid it off. So it's these kinds of secret identity management that systems that are, a lot of companies make money on them today, but that decentralized identity is helping to disrupt by putting more control in the hands of users. And that also means transparent systems and algorithms. So it's really hard to know, what is happening with your data if you have no insight, no way to see the code or the algorithms that are being used to manipulate it. And so a key tenet of decentralized identity is that Wherever possible, code should be open source. Algorithms should be open source. There should be a way for a community to provide feedback. People need to be able to see what happens to their data. Another principle here is that decentralized identity persists as long as the user wants it to. So what that means is, as long as I want this identity, I keep it around. So nobody else can delete it for me. If I want it to last my entire life, it can last my entire life. If I only want it to last for a few minutes, it only lasts for a few minutes. I have control over how long it persists. And it's also portable and interoperable, meaning I can take it with me anywhere in the world that I go. And not just geographically, I can take it across platforms. So I can use it for my Gmail. I can use it for Outlook. I can use it for, Microsoft login. I can use it for Facebook. I can use it for LinkedIn. I can use it across all of these different platforms because it's an open source, open standard. And that gives me that portability and interoperability. The data also cannot be used without my consent. So if somebody wants, to sell my data, for example, I have to give consent to that. I get to consent to whether to share certain things with a third party. So I always know exactly what is being shared about me and with whom. And another principle that follows right on that is minimal disclosure. So I'm only sharing the minimum amount of data needed for that transaction and nothing more. So an example of this people love to use is like if you want to purchase alcohol, for example, in the United States, and you have to show your driver's license to prove your age. Well, that driver's license also contains a picture of you, your home address, your height, your eye color, your date of birth, your driver's license number, all of this data that is not necessary to prove how old you are. And so these decentralized identity standards would enable me to prove that I was over the age of 21, for this example, without disclosing any additional data about who I am. And then finally, the last principle here is that where there's a conflict between the rights of the individual and the rights of the network, the rights of the individual should be preferred. And so, it's saying that sometimes there will be a conflict. Sometimes networks work more efficiently if you take away some individual rights, or maybe they can do things that that other networks can't. But from a decentralized identity principle standpoint, these principles are intended to protect the individual against networks, which are far more powerful than any individual. So, it's not that networks are going to go away or necessarily lose their power, but what these principles do is they shift that balance of power a little bit more back towards the direction of the individual. So the technical elements of decentralized identity are really three. We talked about blockchain already as a distributed digital infrastructure for claims. But then there's also a verifiable credentials standard, VCs, and decentralized identifiers. And these are new technologies that are emerging that are what is making decentralized identity possible. So let's talk a little bit about what they are. A verifiable credential is an open source, open standard developed by the W3C, the World Wide Web Consortium, which also maintains and develops other standards for the World Wide Web. And this standard is designed to solve the problem of information verification across the internet. So the internet was built without an identity layer and without a way of verifying claims. So it's very good at moving information from point A to point B, very good at transmitting information. It is not good at telling us whether that information is true, as we all know. So verifiable credentials are a way of embedding or creating a verification infrastructure for the World Wide Web. And block certs, which I just told you about, is an early version of verifiable credentials. And the next generation of the standard is available now. And so we're actually, at Highland, we're taking block certs and we are upgrading it to this new standard of verifiable credentials. It's also a JSON-based standard, human machine readable, generates any display. It's very open with regards to the kind of data that you can embed in a verifiable credential. Recipients control the verifiable credential because it's signed with their keys. The credentials are tamper evident, so if anybody tries to edit even a single pixel of an image in the credential, verification will fail. The credentials are independently time-stamped at the moment they are issued. Data and display are integrated together. They are shareable, they are revocable, expirable, and legally enforceable because they are signed with digital signatures that are owned by the issuing authority. So all of that means these documents or credentials, they can be verified independently of any software vendor or government. It's decentralized verification that leverages the blockchain for that security. Now, decentralized identifiers are a really cool new innovation. They're basically like new kinds of usernames. You can think of them like a phone number or an email address, which is often what's used to identify people digitally today. But instead of that, they are what's called a DID, and then that DID document is anchored to a blockchain. So you can actually anchor decentralized identifiers to any blockchain, whether Bitcoin or Ethereum or Hyperledger or Sovereign or any other blockchain implementation, and then you own that DID. So most people will have thousands of DIDs in the future. That they will have DIDs for different areas in their life. Like you'll have DIDs for, your academic life, your professional life, your medical records, your civic or government issued records. You can have self-issued DIDs that you issue to yourself. Other DIDs are issued to you by, say, a government, for example, and you own and control all of them. So this also helps to identify you based on the principle of minimal data disclosure. Someone who, has your academic DID does not have your medical DID or your government issued DID or any other kind of DID because they don't need it for the purposes of your transaction. So Microsoft is actually doing some really cool work in this space. They are soon launching the ability to store decentralized identifiers and verifiable credentials directly in your authenticator application on your phone. So they treat a DID like an account. So you can add an account that's adding that decentralized identifier. And then you can create as many of these different accounts as you want, and you control them all. So the technology behind this is just amazing. Microsoft developed something called the SIDETREE protocol in partnership with the Decentralized Identity Foundation, which is a group of companies that have come together to build decentralized identity standards. And the SIDETREE protocol is a blockchain agnostic protocol for creating scalable DID networks. So, if you take something like the Bitcoin blockchain, a new block is added to the chain once every 10 minutes. So that means that a lot of different transactions get built up and registered in that block before it gets anchored to the network. So, if you want to create a DID very quickly, or if you want to create 1,000 DIDs very quickly, you don't want to have to wait, 10 minutes for each DID or even each batch of DIDs. You can, and so SIDETREE protocol was developed to really enable the fast scalability of the Bitcoin network. So it is something called a layer 2 technology, meaning you can think of the Bitcoin blockchain itself, the ledger, as layer 1. And that is a slow-moving ledger that's optimized for security and integrity of digital currency, sound money. But then layer 2, layer 3, you can build as many layers as you want on top of that, and those layers can move very fast. So, you could basically conduct transactions, like financial transactions, using layer 2 applications with even greater speed and efficiency that you can using Visa today, and then it all gets settled to the Bitcoin blockchain once you're done transacting after a certain period of time. So the blockchain serves as a kind of anchor, but you don't have to put every single transaction on chain. And so this allows users to create globally unique user-controlled DIDs and manage their PKI metadata without needing any centralized authority like a bank or a government or a nonprofit or any other authority or trusted third party to oversee any of it. So it's really extraordinary. And then ION, the identity overlay network, is a permissionless open network that implements the SIDETREE protocols specifically on the Bitcoin blockchain. So SIDETREEs can be used with any blockchain, but ION is used specifically for Bitcoin. Anyone can use it to create DIDs and manage their PKI state. It enables, tens of thousands of DID PKI operations per second. And you do not need any additional consensus schemes, validator lists, or special protocol tokens to secure those transactions. So all this is doing is it's leading to a world where everyday transactions like, dropping off a mail shipment or going to the doctor can now happen with an exchange of verifiable credentials using the most secure cryptographic standards available to humanity. And it's just folded into your smartphone and your day-to-day life. So the end result is, in fact, identity you own and can take anywhere thanks to the blockchain. And that is all for my presentation. I would love to invite you to ask questions, share observations. Keep in mind, I'm not an engineer, but I will do my best to answer your questions.
We're very thankful for your presence, Natalie. We're so honored to have you here. So I'm going to start talking Spanish for all the audience out there. Y pues bueno, agradecemos a Natalie Smolensky, nuestra experta invitada en esta conferencia, y con su permiso, abrimos un espacio para atender algunas de las preguntas del público que nos sigue en esta especial transmisión. So Natalie, here's the first question that our audience is trying to know about. So the first question is, speaking about digital money, there's a trend on Twitter regarding NFT. Do you know what that is?
Yeah, so an NFT is a non-fungible token. What that means is it's a digital object, an asset that you can't make a copy of. So it's not fungible. You can't subdivide it into different parts. It's a whole asset, and you can actually own it. You just can never take delivery of it physically because it's not a physical object. It's a digital object. And so, some of these tokens are there are things like artwork that someone has created that's only digital, but they want to be able to sell that artwork. And so they create a non-fungible token for that piece of art that you can then buy. It can also be, silly things. Like you can think of NFTs as like digital Beanie Babies. Like, remember when everybody was collecting them and they were going to be so valuable one day? Most NFTs are not going to be very valuable, but some of them are in fact selling for a lot of money.
Oh, I didn't knew, but that's really interesting, to be honest. So the next question is, can you comment on the concern about the increasing computational resources required to maintain Bitcoin?
Yeah, so Bitcoin is energy intensive to maintain as a network. And the reason for that is because its security technology is all predicated on the difficulty of the computational operations used to validate transactions. So it is energy intensive. However, there are a couple of things that often don't get mentioned when people talk about how energy intensive Bitcoin is. One thing is that the computational energy used by Bitcoin underpins the security of the Bitcoin network and the value of the currency. So it should be compared not against other blockchains, but against the energy that is used to underpin the value of other currencies. So let's think about the US dollar. The value of the US dollar is generated in large part through the military power of the American empire, which is orders of magnitude more consuming of energy than the computational Bitcoin network. I mean, if you just think about how much energy the Pentagon or the Department of Defense uses every year, it's extraordinary. And that is a large part of what props up the value of the dollar. And so Bitcoin is actually creating a global currency that anybody can use and have access to, with far fewer resources than a national military would typically require. The other thing to keep in mind is that in response to this concern, clusters of computers running the Bitcoin protocol now frequently use renewable energy sources and locate themselves in cold climates in order to save on the energy required to cool them. So some of the claims in the early days that like the Bitcoin network would use as much electricity as the entire world by 2020, they definitely did not happen. Computer processing power becomes more energy efficient every year. And so the Bitcoin network does too, but without sacrificing that security and usability that is needed for Bitcoin to serve as a long-term store of value for digital currency.
Wow, thank you. So the next question is, blockchain help to prove the data or document is real or official, but can be used to protect me from cyber attacks like ransomware?
So that's a tricky one. In a way, yes, because the new digital identity technologies that are being built above the blockchain, like those layer 2 technologies we talked about, like decentralized identifiers and verifiable claims, those can be used to cryptographically validate your identity. And what hackers and people who do ransomware attacks often do is they can easily hack into your accounts because the identity layer is not secure. They guessed your password, or they socially engineered somebody inside the organization, or infected your device with malware that grabbed the keys that you were typing in as you enter your password. So the DID standards and verifiable credential standards that are being launched now can actually go a long way to preventing some of those attacks, and they are anchored in blockchain technology.
Thank you so much, Natalie. We know that in this type of events that are so important, I mean, we have a lot of time, measured. But right now, we want to ask you one last question, if we may. And the question is, what would happen with these diplomas if the blockchain chains disappears or ends or is no longer available?
That's a really important question. This is why, when universities ask me, what blockchain should we use? My suggestion is usually, well, pick one that you are pretty confident is going to be around for a while, because the vast majority of blockchains will not be. They are fly-by-night projects that very few people use, very few people maintain, and so they will eventually stop being used. They'll either go away, like the source code will be gone and you won't be able to access them anymore, or you'll still be able to see those old transactions, but there are no new transactions, no one's maintaining the network. And that's like a nightmare scenario. You don't want to have any important data anchored to those kinds of blockchains. And so this is why we actually started out by anchoring all documents to Bitcoin, because Bitcoin is the oldest chain. It's by far the most secure. It's never been hacked. It has the highest market capitalization by orders of magnitude. And so there's a lot of security around maintaining that network, and there are a lot of computational and financial resources behind protecting it for the very long term. And so I would say, if you're not sure, Bitcoin's a safe bet. But there are also government networks that are being launched. So like, for example, the European Commission is launching a European blockchain services infrastructure for academic credentials and other types of government records. And since you have like the European Commission, all of the governments of Europe maintaining that network, that probably also is pretty stable and pretty reliable.
Yeah, thank you very much for your time. Natalie, so any last words, any advice, or maybe some speech, a motivational speech for any people that are watching right now?
Yeah, I would say we are right now in a moment of civilizational transformation. The old political and economic paradigms that we are used to are falling away, and new things are being born. New modes of governance, new currencies, new economic models. And so now is a fantastic time to get involved in that. If you are technical and have any interest in computer science, there's some extraordinary work being done at these international standards bodies that I was talking about, or these volunteer blockchain developers of Bitcoin, Ethereum, and other networks that are doing fantastic work. You know, if you're more on the humanistic or social scientific side, like me, there are many open questions about society, governance, commerce that need social and political resolution that you can contribute your life to. So it's a very exciting time.
Yes, we are very, very honored for your presence, and we're very thankful for your time. And now I'm going to start talking Spanish for all the people that are watching, so we can, you know, wrap it up, and we can say some last words, and obviously thank you in a formal way. Agradecemos nuevamente a nuestra distinguida experta invitada por su interesante y acertada conferencia. Y ahora cedemos la palabra al doctor Nasser Mohamed Noriega, director de Desarrollo de Modelos Tecnológicos, para agradecer la participación y dar un merecido reconocimiento a Natalie Smolensky. Adelante, buenas tardes.
Thank you so much for having me.
So Natalie, on name of the university, it is my great pleasure to extend to you this recognition for your awesome talk you gave to us about blockchain. I think it's not blockchain protected, I have to say it, but this talk will stay on YouTube as well. So everybody that's listening and everybody that will go to YouTube cannot let us lie about your great contribution to the UNL IT Summit this afternoon. So once again, in the name of the university, thank you very much for your presentation, and we hope we see each other on future events like this. Thank you very much.
Thank you, Mr. Noriega. My great pleasure.
Muchísimas gracias por estas palabras. Y bueno, la verdad estamos contentísimos de tener, obviamente, empresas y personajes del nivel de Natalie Smolensky con nosotros. Muchísimas gracias a todos ustedes que han permanecido en esta transmisión totalmente en vivo del UANL IT Summit 2021. Quédense con nosotros, porque seguimos al día siguiente, ya mañana vamos a estar concluyendo este gran evento que está dedicado para todos ustedes, para seguir nutriéndonos en las tecnologías de la información. Agradecemos obviamente a la Universidad Autónoma de Nuevo León, al Canal 53, por hacer esto posible. Les deseamos una excelente tarde.